I have wrecked the... Not understand precisely what I have done wrong, but somehow it's kind of right. Did not attach to the right stream. Alright, I think maybe we made it. Okay. It's an ordeal. I did not set the YouTube thing correctly, basically. Let me get... Correct the Twitch chat, speaking of, seemingly, okay. Discord chat, I think I just said Twitch. That's the one I was trying to find. Okay. We made it. Well, I guess let's do introductions first of all for anyone who might be new or catching this video in the future. If you haven't watched my stream before, my name is Tim. I go by Foamy Guy on GitHub and Discord. On this stream, I typically work on stuff related to CircuitPython. If you don't know what CircuitPython is, you can learn more. I love the fact that there's a frowny face right here. That's actually really funny. If you don't know what CircuitPython is, you can learn more at the main website for it, circuitpython.org. It is basically a version of Python that runs on tiny computers called microcontrollers. You can hook them up to your computer. Most of the ones that run CircuitPython, the way they work typically is they show up like a thumb drive. You edit a Python code file on there. You save it. When you save it, the microcontroller will run the Python code that's inside that file for you. And then your code itself can interface with other electronical doodads, widgets, what have you. Some microcontrollers have lots of general purpose pins, like these Raspberry Pi Picos. Others are sort of more purpose built with like alligator clips and lots of lights, or built-in things like matrix controllers and all kinds of different stuff. So broadly speaking, that's what CircuitPython is. I am jumping back in today on the BMP5XX driver. The SPI version specifically, we got a bit of a revelation yesterday on Deep Dive, so if you want the precursor to this story, you can go check out the Deep Dive from yesterday. Because I basically explained in there what I'm working on, and we figured out why it wasn't working at least part of the way. And now I need to implement the same thing inside of the bit version, the single bit version. Let me also, before we get too far away from the intro, say thanks to Adafruit. Adafruit is a hardware and software company based out of New York. They're the ones who make CircuitPython possible. They pay a team of folks, including myself, to work on CircuitPython code and projects and infrastructure and surrounding project stuff. And they, allow all of the CircuitPython code and project itself to be open sourced, which is really cool. So if you would like to help support them and the open source development of CircuitPython, one of the easiest ways to do it is by purchasing hardware from them on Adafruit.com. You can get yourself CircuitPython compatible microcontrollers, as well as loads of other little doodads to hook up to your microcontroller to make various projects and stuff. Okay. So we are jumping back in on BMP5XX. Yesterday we got the I'm just going to call it RW bits, and just know if I say RW bits, I'm also talking about RO bits, because technically they're the same. This one just overrides this to not work. So some of them we're using are read-only, some of them we're using are writable. But yesterday we got the RW bits working, and the two things we needed to do were add this function. I'm just gonna go ahead and delete the non-working versions of this. We added this function which allowed us to shift a single bit into the most significant bit of a byte. So we can select either 0 or 1, and then it will get shifted into the most significant bit of a byte, specifically of the first byte in the buffer, which then gets written on the SPI bus over to the BMP5X, which I should pull up the datasheet for, because I think so. We're going to work on single bit most immediately, but one thing I think we're going to run into fairly quick is how to handle multi-byte registers, because okay, and in fact this is where we're at here. So the multi-byte burst protocol, host sends the read command, the read address gets multiple bytes and then terminates the transaction. Interesting. So I guess it just knows which registers are multiple bytes, or what? That must be the case, I think. In particular, on page 38 here, in particular, I think around page 50, there's a nice table. Down or... just search for one of the registers. Oh, there it is. Okay, it is on page 50. In fact, I just went too far. When we get into temperature data, and the pressure data, wherever they're at, they are 3 bytes. Here. 3 bytes of pressure data, 3 bytes of temperature data. These are the ones we don't care about. So I wonder on the multi-byte read, does it just know if we select the read, the register 1D, it just knows that that is a multi-byte register, and it sends back not on 30. Okay, so oh no, it does match up. Are we not on 39? 8, I guess. Okay. That's my guess. I mean, it doesn't really say. Shows the multi-byte burst read protocol. The host sends the read command, the read address, and gets multiple bytes, and then terminates. Doesn't really say. And the host is sending the same thing each time, right? This is sending 7 bytes of an address, 7 bits of an address, 1 bit of either read or write, which is the exact same thing that is sent here in the single byte read as is here in the multi-byte read, and there's no, like, you don't send another address or anything, so I guess we'll just hope that that works when we get to it. But first we'll do the individual bits, and we'll want same thing. Maybe eventually we could make a structure where this can get imported from, and they could both use it, but for now I am going to just copy paste it. And so basically when we go to get a, so 2 things actually. One thing was this right here. We need to only write 1 byte when we write the address, essentially. We did see yesterday we were writing 2 bytes at first because that was on end 2 and it's exclusive, so the bytes in the buffer 0 and 1 were getting written. We want just 0 to get written, and then the other thing we need to do is this shift here. So for when we want to do a read, which is what this get property is going to do, we need to shift a 1. I think it was. Yeah, shift a 1 into the most significant bit. And then when we're going to do a write, and we're going to send the address, actually it looks like I did not do this part, we want to shift a 0. That. And I guess we'll see how far we get, but I may go and sprinkle some more of these print statements around if it's not working. Broken the chip ID read again. Oh, this was wrong. We don't want to do this. I shouldn't have done this. So when we are writing, we actually need to send more than 1 byte. We need to send the address and obviously the data we want to write. Yeah. So when we're writing, we do need to send 2 bytes. I changed that to a 1 we should not have. Which probably then, I'm guessing that messed up the reset. Okay, yeah. So now we got a lot further. We've done a bunch of things, printed out a bunch of stuff. It did not raise any exceptions, which means all those checks that are inside reset must have passed, like chip ID, NVM error mode, NVM ready, something. There's a couple of different ones in there. Oh, it did reset, and then after it reset, looks like it failed one of those checks. Take a look at what that one actually is. But we made it further because the last one that failed before we had the bit, RW bit in place, was an NVM thing. We tried to read the status of the interrupt POR, power on register, and turned out to be false, although we did. I think that's from further up though, right? Yeah. Writing? No, reading. For reading, we want to only write 1 byte. Writing, we want to write bytes. Okay, yeah, and then this, I presume this will correctly shift the value we're writing, either 0 or 1, into the correct location based on the bitmap, bit mask. Let it try and see if it does the same thing again. Yes. Let's look at what is. I mean, it's only a bit, I think. Look at this code. So it's just doing data ready, and then we never make it out of a init. Off these, because we seem to be getting past that point. I'm gonna go into here and some. We did this after we shifted, but before wrote. And again after we single bit. We went to read this register. Let's just validate that the address is correct. 57 at the ooh. No. Status, so that's reading the register. Interrupt status register. It's trying to get a single bit out of it, and that register is supposed to be 27. Well, okay, but we have the 1 there. We have the 1 there. We actually want only 7 bits of this. Good morning, C. Grover. Nice to see you this morning, my friend. Okay, yeah, so it is 27. Okay. So we got the right address, and we got our 1 shifted in for reading. But just when we got data back, it was 0. One thing that is a little interesting is on the one before, right here, the data we got back is in, but I thought most of those checks were... should be Booleans. So we should be getting either 0 or 1. Got back 10, which is too many bits. Eight. So is status NVM error? Yeah. And ready. Both ready and error are on 28. So it would have been reading which one first? It did the chip ID check here. And then it would have been checking NVM ready. So it did that and it got back 1, 0. Back 2 bits. Well, in its buffer, it got back 2 bits at least. So, okay. And which one is which? So this was... want to... thing that's... one at all. Because that's truncated. It's truncated again. So NVM ready is in bit 1. NVM error is in bit 2. But, and those are indexes, offset. So 0 is core ready. We're not messing with. NVM ready. It's offset 1. But 2, we're only getting 2 bits back. What's up, Johnny? Nice to see you today, my friend. Bit offset 1, bit offset 2. So in the case of NVM ready, which again is the first one, we got back binary 10. We would have been presumably trying to find bit offset 1, which would have returned 1, which would have allowed us to get past this. And then status error, status NVM error, we access next here by reading the same register, but still getting right, but still getting 10. Okay, so the thing is, I guess there's hidden zeros here, right? Because we got back a full byte, right? So we actually have, there's actually 6 hidden zeros here technically, and there's 6 hidden zeros here technically. So bit offset 2 was 0. 0 is false, so this does not happen. So that actually did work fine, and the fact that there's not enough bits is not true. It's just that when this prints, it's not padding them to 8. And then this, though, still is false, because it got back 0. And that is set up as bit offset 4 in the register 27. UR or software reset complete. Okay. I mean, the only thing I can really think of that means is that it's not complete. So maybe we should sleep longer before we try doing this stuff. Let's try sleeping like way longer. Still the same thing. Okay, so it's not something where it's just like we're not waiting long enough. Would there be anything like specifically we need to wait in between here? I mean, not really. But software reset complete. So we are not, I think we are not writing the reset correctly then, I guess, which is back up here, but everything else happens successfully. Did I comment? I didn't comment it out, did I? So command It's this. That's 7E, which is, I'm fairly sure, this one. Ooh. Wait a minute. Okay, we got the same thing. So there's a leading 0 there. I really should make that pad to 8, I guess. We write setting into 7E. Value we're going to set as B6. Go fine. We do read immediately after. Not be that. Okay, so it's... Okay. This is not the set, actually. This is... We need to read the data out of the register, put whatever bits into it we're going to put into it. In our case, it's a full byte, so we're just going to set a full byte of it. And then we need to write those bits back. So in our case, like I just said, it's a full byte. So it's like, this is kind of an exercise in futility. But if we were doing like 2 bits, for instance, we would need to get that full value back out of there. I mean, get the value out of there to begin with, put the 2 or 3 or whatever bits we want into it, and then we need to write that full byte back. So we are actually reading here, which means we need to only read, we need to only send the address and the read-write flag, and we need the read-write flag to be set to read when we do it. So I am going to add RW bits set before read into. And this is RW bits set before data write. Really need those. Yeah. So because this reads, and then this adds our bits to it, and then this finally, well, this puts it back in the buffer, and then this finally writes it back out. And we would want to, well, I guess it doesn't need end 2 because theoretically it could be more than 2 bytes. Need some coffee. Thanks for the reminder. Yeah, coffee cheers there. Yeah, okay. But we don't want end 2 because theoretically we could be writing multiple bytes. I don't think this driver needs to do that. We need to read multiple bytes, but nothing changed. Yeah, so we could tell that it is different because now old register is 0, and before old register was FF, which was because we were actually failing the read. But again, because it's the command, and the command is actually 1 full byte, that actually shouldn't have mattered. Because the effect of that would have been that we would have gotten ones, we would have clobbered any zeros with ones in the register. But we overwrote every bit anyway. And we overwrote it with the reset command. Wait, where is our is this the old one? Where is our RW bits before data write? Oh, one more thing. We need to we need to shift back in a 0. We need to shift back in a 0. Because we are going to be writing, but okay, wow, I don't know. That was a thing that happened. What those numbers looked correct, so... I mean, command register... I don't know if a register can be write only, but it can. That's basically what the command register. Well, okay, no. I mean, there is write only, but it does not list itself as that, so. Went too far. Okay. We still have FE here. Why do we still have FE here? Oh, because I did this before. We need to do this. Should have 7E there. That's the address. Okay, there we go. All right, so we read the old value. We wrote the new thing we want to write into it, into the register. We put the register in our buffer. We presumably wrote it. Let's go look at the command register. If it says anything about like... B6, we're sending this. Triggers a reset. All user configuration is overwritten. If this is set using I2C, an ACK will not be transmitted to the host. Not sure that I understand what that means. Register will always read as 0. Reset is basically the first thing we call, right? And this ultimately traces to where we crashed. 235, we're in reset. 292. So we did this stuff. And everything was correct. The chip ID was correct. The NVM was good. But it just doesn't show that it powered on successfully. And so this is interesting. If this is set using I2C, an ACK will not be transmitted to the host. Maybe that's just altogether like a thing that happens in I2C specifically. And they're saying for the command it doesn't. What's up, Yoshi Boy, over on Twitch? Going pretty good. Yeah, I don't know I2C protocol well enough to know if that's true, but what it looks to me like is maybe I2C is kind of like by default doing the ACK thing here, and specifically for the command register, it's not gonna. What's going on here? I wonder why is there an extra bit here? Kind of on this one too. Got back all zeros. What is the default state of this register? We're reading the interrupt status register 7. You were interested in this bit. All of these do default to 0. Clear on read. You mess it up by reading more than once? No, because that's the only one that's in that register. We read here. We got back nothing. Got back all zeros. Okay, so for writing bits, we have the same problem here. Maybe, I mean, we're not writing any bits. I don't think so. I don't really think this is the problem, but I do think we have the same issue as we would have had over here. So I guess let's fix it. Print statement, and we could see if it's happening or not. Basically, we would want shift into 0 for writing and to shift into 1 for reading before we but we're not calling any sets on any single bits at any point here. So it's tough to say, like, is the writing broken? And the writing being broken means that the reset command is not working. Since the reset command doesn't work, we never get the interrupt that says that we reset correctly. Do I have a logic analyzer? I do not. I probably should if I want to be doing this kind of stuff, huh? I have a Pico debug tool. Does that help at all? Supermath? I've never used it. Certainly not for logic analyzing. I think maybe I used it as like a UART bridge or something once, but I guess what you're getting at is probably like reading the wires and trying to figure out if it's actually doing in the wires what we think it's doing. So this is interesting to me that I notice now that it's, I mean, we would be only getting a byte of that. Isn't there a debug flag for register or bus IO to print what it sends? That's a good question. I don't know. Well, so yeah, it's tough. So like bus device is hard a little bit because it doesn't. If these were wrong, we would be like totally wrong, right? Need a logic analyzer, use a Pico. Oh, so not even a debug. Copy. Curse you, Discord. Wait, what was it before? I figured this out. Wow, what was it? It was like hold shift? I don't know. Oh, it was highlight. It was highlight? Not today, Discord, not today. Yeah, I should probably set this up. Well, I should probably get a logic analyzer, like, generally speaking, but well, then I should probably set this up. Let's check for debug too. So I was trying to just, so I should actually probably try to also verify all of these things are correct. Presumably those are important. I don't see a debug here. Let's look though, because I did just actually discover as well before this. This is kind of like, one thing I found weird yesterday is like, this example is calling read into and write, but it's, there's no functions in the docs for read into or write. It's just create this. But I figured out this is actually changing it into busio.spy. If there's a debug on set, let's IT. In two-player. I don't even know what that means. I'm thinking of Arduino. It defines debug. Figure. Right, read into. Sequence. I do not see. Debug. Do check all of these things though. So guess active to be high. No. I mean, is active when things are happening? Because it looks low when things are happening. Let's see. What do they call it? Protocol. Oh, maybe we need to be doing a protocol thing. Do that. Protocol is automatically selected based on the behavior of the signal on the chip select pin after power up. Power up. After soft reset or power up, if the primary interface of the device is I2C. Oh. Okay. But when it comes on, it's in I2C mode. If it's connected to I think that's what that is, but I'm not 100% sure, I guess. During power up and not changed, the primary interface works on. Okay, so default is I2C, and if it's connected to high, then it goes to I2C. So presumably the default is that it's connected to high. For using that, it's recommended to hardwire that to that. Its power on reset is only. Ooh, this is the register we're reading. Since power on reset is only executed when both VDD and VDDIO are stable, there's no risk of an incorrect protocol detection due to the power-up sequence. Okay, I don't know what that means, but that's okay. Once the pin is falling low, the mode is disabled. HIF, hardware interface? Why is that different from primary interface? Which is the SPI mode. If there are at least 16 full serial clock edges during the low phase, and it has risen again. Hence, it is recommended to perform a single read via SPI of registers, e.g. to chip ID before the actual SPI communication with the device. You know, come to think of it, now that I see that written here, I think I saw something like that in the Arduino driver. I saw something like that, which I should have open and don't. So inside of init, do a soft reset. I'm gonna open this here. Stuff. Do a soft reset. I'm not sure what's in there. Init. I'm not sure what's there. Pressure config. So I mean, this is good. Just going on to do stuff. It's definitely not doing a SPI thing. So that must be inside one of those. Soft reset. Balls. Okay, if it's on SPI, performing a single read to get, yeah, this. Okay. So that is where? That is immediately after reset. Because this is setting the register to the reset command. But we already do that because we set the reset command here. We look up the chip ID here. Is it possible this is bad, actually? I guess that could be. In which case, we should get rid of this one too. We got the same error. There is this delay here. Soft reset execution takes 2 milliseconds. We'll wait a little longer. Times 3. I think this is where I got the 6 from, actually, anyway. We did soft reset. We did wait. If we're on SPI, then it immediately tries to read the chip ID. I'm not watching live, but I wrote something up on that a few years ago. Nice. Yeah, I will definitely check into the Pico. Definitely check into the Pico stuff. I mean, how can this be? I mean, this says a single read via SPI of registers before the actual communication. But we already sent the reset. Well, that's the sleep. We already sent the reset command, which is not actual communication. Is that what we're led to believe? So set registers. Make sure the device is not null. Make sure that the register data is not null. If we're using SPI interface, write the data to the register address. Dev intf result equals dev write index starts on 0, so write register address plus index, register data plus index, write 1 byte, presumably that means. And I'm not sure what this one really is doing. But then increment this. Keep going until we get to the end of the bytes. If it's I2C, do this. So I almost think, like, to me, the reset command, I mean, in my mind, the reset command is actual SPI communication. It's a SPI write. We're writing a byte. We want it to do its thing. I mean, if we were not getting into SPI mode, it would be really weird that some of those registers are coming out correctly. But to my eye, this makes it seem like we might not be getting to SPI mode. So I'm gonna try like this, where we have like chip ID before. I think I even was printing that at one point. And I mean, I don't really care what it is, but I am a little bit curious. Because it said it would be the wrong value or something. It said it would be wrong. We do still get the same thing. It was 80. It was correct. I think, unless we got that hex thing again. No, I think that's correct. So my device confirm. Device is here. So what are the defaults? So chip select. Okay, so CS active value defaults to false. Okay, so that must be fine. The baud rate defaults to this. Polarity. Base state. Clock pin. Is the polarity of the interrupt pin. I think, which is a different thing. It looks like there's two modes. Mode 0 and mode 3, which are opposites of each other. Why there's not more. Okay. Out of curiosity, what if we just skip past that? I mean, I assume it doesn't work, but like, I am curious what happens. It does work, actually, is the answer. Okay. I think those values are basically correct. I'd have to probably hook up an I2C one to make sure, but those look correct to me, just eyeballing it. Okay. So the driver basically works. And actually, the fact that these numbers are correct-ish, again, just eyeballing it, I think they're correct. That means that the multi-byte ones are also fine. So really, we have just this problem only. Does the Arduino driver check the power on register interrupt or not? So this is init. That would where it's at, I think. So, well, soft reset. Hmm. So we are in fact having a problem checking the power on reset interrupt status. So that makes this interesting. It is effectively like turned off, right? If 0, so this is not actually getting done. But it's basically like get the chip ID. It will get put into here. So if the result of getting the data from the register was okay, yeah, so it is still, I mean, it is still like after though in my mind. Because it did already set the reset command all the way up here, but in any case, it read the chip ID, but that's like a throwaway read. We check if it was okay, then we get the interrupt status. We check if that was okay, and then we check if the status presumably is equal to 1. That says let's see. Oh. Okay. And and is it's it to the correct index. 0, 1, 2, 3, 4. Okay, yeah, so that's checking if the index 4 bit is high. So this is commented out, basically. Just commented out. It does work in the I2C driver though. This does not raise the same exception over there, or at least it didn't when I tested the other day. So that's weird. But everything else seems to be fine, so I'm kind of inclined to just not really care that much since this one is not doing it. We could basically do the same thing. Like, we could basically write this. I mean, the way this is worded is a little weird too, though, because it says, like, suggestion by Bosch to fix init problem with checking the pin. But this doesn't really seem to be, like, fixing a problem checking the pin. More so, it seems to be, like, doing the actual checking. Like, it's getting, well, not the pin, but the interrupt status, the bit. Yeah, it doesn't seem, like, if anything, this would be the fix, I guess. But it's still odd to me that it comes after this. But in any case, since the rest of this is working, I think I'm sort of kind of inclined to, like, do my best to just not worry about it, honestly. We could basically put the same comment, I guess. Let's do that. Suggestion by Bosch. Don't super care for the wording. I'm just gonna say suggestion by Bosch to check int status POR. But I'm gonna leave it commented out the same way as it is in the Arduino driver. And then basically everything's working. It's pretty. Was the wind exiting my sails? Let me take out the chip read. Let me take out the read that's before the reset. That's bad. All right. Well, I'm at a loss there because it was definitely just working. And I didn't change anything. I mean, I took this out and that made it work. And then I added this comment. I have not touched anything else. Is that true? I'm pretty sure that's true. I mean, if we turn this on, we don't even get to it. We just always fail. Hey, thanks for the follow on Twitch, Yoshi Boy. It was a little while back, about a half hour ago. Sorry, I didn't have the did not have the thing open, so I didn't see it back then, but I do appreciate the follow, my friend. Boy, that is rough. Like, legit, it was just working. It's crazy. Okay, I don't even know. I think we may be pretty much... Like, it feels bad to want to give up after seeing it actually just work for a while. But the sense that I'm getting is that it's not stable, basically. We have that sleep in. I mean, the Arduino driver is also not checking these things either. Well, I guess we could comment those out too, but I don't get at all why. Okay, so here's our reset command. And then getting the chip ID. Here. Yeah, because chip ID is register 1. And then getting NVM, getting status NVM ready. And we got back 1. There's our first kind of successful data reads. Or what all of this stuff is. Well, it must be setting the configs or what all the gets afterwards are. reset command, get the chip ID. Yeah, before we were getting 10. And actually we were getting 6 zeros and then 10. And now we are getting 1, which is going to be 0 for ready and 1 for error. Well, I don't even know what the 0 bit is, I guess. What is the 0 bit in the register, status register 8? Reserved. Okay, so reserved is 1. Core ready. Not reserved. I look. Oh. Wait. Did I look at the wrong thing? Maybe I looked at 20. I don't know. I don't even know what I looked at. I'm all out of whack now. They matter. No, it just is wrong here. This says reserved 0. Unfortunately, we can't tell. It just says status, but then it says reserved 0. But if we go and look at it, here it says status, and status, no reserved 0. And it says core ready, which I have no idea what that means. The only 2 references to the word core are in this whole document are right here. But that is being 1, whereas before it was 0. But ready is being false. Should we just try waiting longer? I don't really think that's going to fix it, but... If asserted, then it's ready for operations. If asserted, it indicates an error due to at least one of the following reasons. Power transition fail on NVM power request. NVM timeout errors. The charge pump voltage fail during last reboot command. Bit is cleared, updated upon a new NVM command. If boot command is executed. I don't really know what that means, honestly. Okay. Over. I don't know. I mean, I don't even really know what the NVM thing is all about, honestly. Maybe when we write these registers for configuration, it stores it in NVM. I don't actually know I don't actually know what it's doing with NVM. Okay, so there's a couple of bytes that you can write to and read from. Can I read the interface? That is Rev ID interface. Yeah, I don't know. I mean, I don't think that we're writing to NVM unless if the configs are writing there, like when we set oversampling rate like this, which just went away because I actually unplugged the microcontroller. Plug it back in. See, I just plugged it back in and now it's actually working, so basically it dies. It only works once from power up. Yeah. So it works once. But if you stop it and then try to restart it, it fails. Okay. Not a total failure. It's kind of close, I guess. I don't know. Did I try? Yeah, turning it off and on again. That was from a couple of minutes ago, actually, and I did not until just now, and it turned out that worked. I tried the reset button earlier, but the reset button did not fix it. Only explicitly power off and then power on fixes it. And unfortunately, this doesn't really like tell us anything useful. So here's where I got those things that it was checking before. Post power up. Let's read a few of these things actually. So mode depending register write. Number of registers can only be updated when it's in standby mode. These are, for example, the registers for NVM operations, C3.8, but also configuration registers. Hmm. Well, okay, yeah, we're doing that. Well, some of them. These ones we're doing after. But IR filter and oversampling we're doing before. They'll say only some of them. But that's maybe? But I mean, standby. Be in standby, I assume. Post power up. After power up, it's available after a variable, which we put somewhere else. The hosts should not initiate any communication before. Depending on the interface configuration, a dummy read before 1. I think that's what we saw before about by trying to read the chip ID. Recommended that the host checks the following after a power register. Chip ID to make sure that it's not all zeros. We're actually just going ahead and making sure that it is one of the expected values. Check the status register and check that NVM ready is 1 and NVM error is 0. Check the POR register and check that it's set to 1. And that's what we were trying to do. And so this was not working under SPI. These kind of work once under SPI. I wonder if we are... No. My best guess is like... Are they banned already? My best guess is that maybe we're violating that rule of don't. So my theory is that from a actual power off state and then turn on the microcontroller, my theory is that there is more time between when the breakout gets power and when we do the first thing with it. Which to my eye, the first thing is currently this chip ID read before it was this command setting here. Doesn't really seem like that's making a difference, truthfully. But my theory is basically there's more time after the thing has power and before this happens when CircuitPython is also booting up due to being powered off. But when I reset button, maybe there's less time. And more specifically, maybe there's not enough time. So, like, really the only thing I could think to do is, like, wait before this a little bit more. That does not do anything. Still just the NVM is not ready. And the datasheet doesn't tell us, like, why the NVM is not ready. Just that it is not ready. So I don't know. I'm going to try resetting it again. But that's just going to infinite loop on NVM is not ready. So that's not useful. So basically just NVM is not ready anytime except the first time. And status POR doesn't seem to work at all. If we just skip the NVM check altogether, though, then it works. First time. And the second time. And the third time. Presumably it continues to work. I am kind of inclined to also remove the checks for NVM. The datasheet says you should do that, but it's not really working. And the actual data is working, so I don't know. I mean, I'm kind of to the point where I think that it feels like these are fine to me. Feels like the register SPI classes are working basically correctly. But that there is some, like, issue with when it is in SPI. And it tries to restart, basically. I mean, would the reset button, like... Okay, one thing I need to do is compare to I2C, I think. We should make sure that I2C doesn't have the same problem. I don't think it does. I'm like 99% sure I would have done Control-C, Control-D before. But I'm not 100%, so I'll check that. If that has the same problem, then I think we definitely just remove it from both drivers, since the Arduino one doesn't check anyway. If the I2C one does check but doesn't have a problem with it, like the SPI one, then that is weird, and I don't really know what to do about it. It feels a little bad to not check at all if it is working on the I2C side, but another thing that I would ultimately like is ideally to set up the classes such that this stuff doesn't have to be repeated. And I have only a rough idea in my head of how that's going to work, but it's kind of like, I'm hoping that we can import, that we can have two different files and import the correct one of these, and then we're gonna have to, like, I don't know how it's gonna work, actually. Can we, so I think how it's gonna need to work is we're gonna need to accept both, actually, a handful of constructors. I don't know. Anyway, I'm getting ahead of myself. At some point, I would like to like, if we actually do keep the SPI driver, I would like to figure out a way, ideally, to factor this out so that it, like, the SPI driver and the I2C driver basically share this one big chunk of code. That's kind of like the primary benefit of having SPI bits, RO bits, and RW bits that match the I2C interface. It would be that if we could get this to just import the right one and use them, then this whole chunk of code could just work for both, basically. And if we do make it that far, then they're both going to share a reset function. They're both going to share mostly pretty much everything. So it would be a shame to have them be different, where it's like the I2C one's trying to check, the SPI one's not. But in any case, I sort of feel like I am rambling a little bit at this point. Yeah. Really, my best guess for why it's not working is it's somehow still in normal mode, and maybe the NVM doesn't count as ready in normal mode. Maybe it only counts as ready in standby. Can we read the mode? I don't remember what the mode register is called. Look like it has the word mode in its name, though. Okay, so it gets weird because tries to use, well, there's like a deep sleep mode, which kind of counts as a mode, but kind of doesn't count as a mode also. ODR config. ODR config is right there. Power mode is read write. So we could read the power mode when we first come up to try and check if we're in normal mode or standby mode. Maybe we're still in normal mode, and maybe the NVM stuff is not ready until, like, is not ready outside of standby. That's a theory. Not sure. But I think I'm going to call it a day for now. So thank you to everyone for hanging out in the chats. Thanks for anyone who's watching along. Even if you weren't in the chat, I appreciate you as well. I should be back next week for the deep dive at the normal time, 2 p.m. Pacific, 5 p.m. Eastern, 4 p.m. Central on the Adafruit channel. I should also be back here on my channel Saturday morning, 10 a.m. Central Time next week as well. Until then, I will bid you farewell. I hope you have a good rest of your Saturday, good weekend, all that jazz, and